Sir, good afternoon, sir. We welcome you to the sixth day of the presentation. So today you are handling the 11th
11.
session, 11th session, sir. So your session will go up to 3:30 p.m., sir.
Yes, yes, sir.
So kindly handle your session, sir.
Thank you. Thank you so much, sir.
Thank you, sir.
Thank you, sir. Thank you for inviting me for the second session as well. Thank you for thank you to Sambasura sir and NRI Institute of Technology in Vijayawada and AICT et al. For providing the fund for this workshop. So today I'm going to present on the topic deep learning hands-on. As I promised that I will give the complete hands-on session so that people will not get bored. So if you have laptops, so you can keep your laptops with you, and they can use that collaborate research.com. I have shared one file with Sambashira sir, and he will be sharing with all of you so that we can use that file for today's hands-on session. And so quickly, let me explain about the complete deep neural network with the details. That means the background mathematical details. Should I go with the theoretical explanation for half an hour and hands-on for 1 hour? Is it okay for all of you? Can I see some hands at least? Or should I go directly to the hands-on without any theoretical explanation? Which one? Let me see the hands. So all of you, please down your hands so that I'll ask. Should I go with the theory and practical implementation? So how many of you are okay with this? Fine. 3 people, only 3? Yeah, fine. So I'll go with the theory explanation first. I have prepared a nice slide for understanding the concept of CNN in detail. And let me keep some 2-3 empty slides so that I'll explain about the neural networks also once again. So the presentation is mostly explaining the concepts of how convolution process will work, what is max pooling and what is stride and padding. So one application that is digit recognition, how digit recognition can be done. What are the possible case studies that we can use for the using the CNE, and all those things have been kept in this particular thing, research scope and all. Since all our faculty all discuss in terms of with respect to the research, not with respect to the theoretical, that means classroom explanation. So as I explained in the previous first session, in my first session, I explained that the basic NN has been started with the some linear regression problems where y is equivalent to y cap is equivalent to mx plus c, where m is equivalent to slope and c is intercept that we have seen. So we have to actual y, that means we have to predict the next variable. It can be a stack, a stock, or anything. We have to predict the next timeline value. So for that purpose, we are calculating the y cap equal to mx plus c, where x is the previous sample. This has been replaced as y cap is equivalent to, y cap is equivalent to this can be replaced as y cap. I'll use general. Yeah, fine. So basic explanation is there is a graph in the it is having some linear term. It is a time series data. So each time, what is the value that has been mentioned? So then we have to calculate the next value. If you want to calculate the next value, then what you have to do? I'm going to use the formula y cap is equivalent to mx plus c. This has been translated to in our neural network. Y cap is equivalent to wx plus c, wx plus b, sorry, where w is weight and b is bias and x is previous sample. These things we have discussed in the first session. So wait, now if X is an input, it has to be given to the W and it will be connected to the neural network. There will be some activation function. The activation function can be depending on the data set that you have taken. If the data set is in between 0 to 1, then sigmoid activation function we are going to use. That is sigmoid activation function, which is the 1 by 1 plus c power minus lambda. And this weight x wx, and we are going to give the bias also. Wx plus b with an activation function, it will be z equal to wx plus b. In the activation function, what we are going to do is we are going to apply sigma of z. Then it will be given to the y cap. Now this y cap may not be the same as y. There will be some y. Actually, it will be original value is y and computed value is y cap. Then what we have to do? We have to find the error between the y and y cap. That is y minus y cap. Generally, we will take the whole square because sometimes it may give the positive value, sometimes it may give the negative value. If you take whole square, it will be normalized value. So then it will be called as squared error. Yeah. So this way we will find the error. This will be error. Now based on the error, what we will do is with respect to the error, we'll change the weights dw by de. So this is a partial differentiation process. So we'll get the new weight. That means the difference will get delta w. The difference estimated and the previous w and delta w will be added together to get the weight for the next iteration. That is w plus 1. This is w0. W1 you will get. So same process will apply. Then again you will get the error and we'll change the weight. So you'll get w2. So this process will be iterated till the weights gets converged. In this process, we have seen the errors will be converged in this way. Initial error may be here, next year, next year, next year, and it may go like this. So this is gradient descent approach. In this way, the error will be the weights will be converged, but it will take lot many steps. The weight the error value will go up, down, and all. So finally, when the weights converge, the error will be the minimum value. So, and people are doing research in order to reduce the number of steps in between. So directly we can reach to this minimal value in less number of steps. That is one aspect of research people are doing it. This is the next information about the neural network. Now, suppose if I have a sample, let us assume that I'm having a table. In this table, I'm having dependent and independent variables, where my y will be the dependent variable and remaining all are independent variables x1 to, let us assume that there are 4 features x1, x2, x3, x4, and assume that there are 256 samples. So first sample, second sample, and we have the 256 sample also 0, 1, and 255. So the matrix is of size 256 by 4. The matrix is of size of 256 by 4. Now what we can do, how the neural network looks like in the sense. So there are four neurons, sorry, 4 input neurons, x1, x2, x3, x4. It will be connected to this one, hidden, that is hidden network. The hidden layer will be having, let us assume that 6 or 5 hidden neurons. Next level, it is having 3 hidden neurons. And finally, it will be having only one Y. Assume that each input will be connected to the hidden neuron. Each input neuron will be connected to the hidden neuron like this. Then we each input that means each neuron of input layer will be connected to the hidden neuron. Neurons of hidden layer, I can say. Imagine this way. Will be very interesting concept of understanding the concept of neural network. So this way it has been connected. Fine. Finally, it is connected to the output layer. This is my output layer. So now assume that what are the values? So this will be W11 indicating that X1 is connected to H11. Let us assume that this H1 level. This is X2, this is X3 and X4. H1, H2, H3, H4, H5. Or I can say H11, H12, H13, H14, H15 because assuming that it is zero layer 1, H2, H21, H22, H23. This is the output layer, that is O1. Now, X1 is connected to W11, W12, sorry, W13, W14, W15. So that means Wij indicates that ith input node is connected to jth hidden node. That is the indication here. So assume that now how many connections will be there totally? 4 into 5, that is 20. The matrix is of size 4 by 5. That is W11, W12, W13, W14, W15, W21, W22, W23, W24, W25, W31, W32, W33, W34, W35, W41, W42, W43, W44, W45. This is the matrix where our input matrix is X1, X2, X3, X4. Now it is of size 4 by 1 and it is of size 4 by 5. We cannot multiply 4 by 1 with 4 by 5. So we have to convert to this X transpose we have to do. X transpose if you do means it will be converted into X1, X2, X3, X4. That is 1 by 4 matrix. And this is 4 by 5 matrix. The resultant will be 1 by 5 matrix. So the number of columns in the first matrix should be equal to the number of rows in the second matrix before performing the multiplication here. So it is one that means it will be H11, H12, H13, H14, H15. So this is the operation that we are going to do. Now, what will happen? X1 into W11 plus X2 into W21 plus X3 into W31 plus X4 into W41 will be the value of H1. And similarly, X1 into W12, X2 into W22, X3 into W32 plus X4 into W42. That will be the H12. Likewise, we are getting the 5 values. We are getting the 5 values total. Yeah. H11, H12, H13, H14, H15. So we are getting the 5 values from this particular matrix. Also understanding. So now, once it is done, we have to perform the activation function here on each and every H11. So we'll reach to this position. Yeah, we'll reach to this position. That means
నేరస్తుడు ఎంత పెద్దవాడైనా పోలీసు వాడిని అరెస్ట్ చేస్తుంది. జనాలు చెప్పు తీసుకుంటారు. కోర్టు వెంటనే
fine. They're watching movie, it seems. Today Saturday, right? Yeah, Rajnikant movie. Anyways, fine. So we'll after applying the activation function, we'll reach to this position. Now after reaching to this position, we'll get another matrix V11, V12, V13, V21, V22, V23, V31, V32, V33. Likewise, now you can imagine there is a 1 by 5 matrix. And the matrix size of here we will get the matrix of size V matrix will be of size 5 by 3. Can you imagine this is the 5 by 3 matrix. 1 by 5 into 5 by 3 will give the 1 by 3 matrix. So that means these values will get very beautifully organized, right? These values will get. Again, we'll apply the activation function at this stage. Then we'll reach to this particular position. What is the size of this matrix now? 1 by 3. It will be multiplied with, it will be transposed and multiplied with 1 by 1 matrix. Or 3 by, or otherwise I'll multiply with 3 by 1 matrix. So it will be multiplied with 3 by 1 matrix directly. 1 by 3 will be multiplied with 3 by 1, we'll get 1 by 1 matrix. That is input of the output layer. So again, we'll apply the activation function, we'll get the output of the output layer, we'll reach to the here. So this is y cap. That means this operation we are doing on random weights on the first sample. Then we are going to calculate E1, which is equivalent to y cap 1 minus y1 whole square. That is error 1. So after getting the error, we are going to do the back propagation on modifying these weights and modifying these weights and modifying these weights we are going to do. Then we'll get the new weights. After getting the new weights, we are passing the second sample. So we have to pass the second sample to the network. The network will give the error, that is E2. Okay, that is Y2 minus y cap 2 minus y2 whole square. After getting the second error, again we are going to change the weights, adapt to new weights. And we are going to give the second sample, that is 0, 1, 2, second sample. Otherwise, 1, 2, 3, you assume because even you, yeah, 1, 2, 3, you will get E3. Likewise, how many errors you will get? E256. 256 errors will get. After getting 256 errors, what we will do is we will find the average of all these errors, mean of all these errors. Mean EI. It will be 1 by 2m, that is 1 by m, but 1 by 2m they will do, or 1 by m also you can do. EI. So this is the total error obtained for one epoch. One epoch is nothing but there are 256 iterations will be there. Since the data set size is 250 with the 256 samples, then we'll be getting one epoch. This will be one epoch. So we'll get the epoch error. Epoch error will be the summation of this thing. That is 1 by 2m sigma yi minus y cap minus yi whole square, or yi minus y cap whole square. Anything is fine since we are finding the square of it. So where I equal to 1 to m. Okay, so this will be called as root mean square error. Or mean squared error. 1 by 2m we are doing that, root mean squared error is fine. So this way we are going to find the mean squared error. So for one epoch, so we'll be plotting here. Likewise, we'll be plotting the next epoch error, next epoch error, next epoch error, and all those things. Finally, you will get the optimal error. So this process will be called as gradient descent. Here, why this much of explanation I had given one more time in the sense, in detail in the sense. So we have to understand how many hyperparameters are required. Here, how many hyperparameters? 20 are required. 20 plus, there will be bias values for each and every hidden layer. This is very important because I'll explain in detail with the coding. I'll show this in the code also, I'll show this kind of architecture. 20 plus 5, that is equivalent to 25. Fine. Here, how many hyperparameters are required? 5 into 3, that is 15. 15 plus 3, that is 18 hyperparameters. Why 3? There are 3 bias values. Then in this case, 3 by 1, 3 into 1 is 3 plus 1, 1 bias value. That is 4 hyperparameters. for this particular architecture, we need 25 plus 18, 43 plus 4, 47 hyperparameters are needed. The same thing I'll show in the system and I'll show the model summary. You should tell me how many hyperparameters are required if architecture is designed with that. So this is what you have to understand at this aspect. At this instance, sorry. Fine. Is it audible to everyone?
Yes, sir.
Can I hear one? Fine. The process is fine, right? Everything is clear, right, as of now? The neural network part.
Clear.
Yes, yes. For this one, we have to extract the features manually and we have to feed here. That is one drawback that we have to understand. We have to identify the features. If you are doing image segmentation, image features we have to extract. If I want to identify the speaker information, then I have to extract the features with respect to the speaker. So that kind of manual extracted features can be fed to this particular neural network. Now I'm explaining how to extract the automatic features by using the CNN. So that means no need to extract the features manually. We can extract the features automatically by using the CNN. Convolution part. So till now we have learned the NN part, neural network part. Now I'll explain about the convolution part. The combination of convolution and NN will be the CNN. So this will be explained for one image data set and one time series data set. I'll explain. Yeah. Now coming to the PPT. Now see the PPT. One can look into the PPT now. Sorry. Right. So learning hierarchical representations. Generally, the CNN will be used for either text or signal or images. Only we have three applications. That means either we wanted to predict the text, either we wanted to work on the NLP, natural language processing applications, or we wanted to apply perform on the signal based applications. What could be the next value, and it can be time series data, signal, speech signal, and the next part would be image. Image is nothing but it is a matrix. That is, we can say matrix representation of data. So image, whenever we are talking about image, so the basic element of image will be the pixel. Then what we can observe, if you are seeing me, you can see the edges of human being. So then edge detection can be done. Then part, that means we can separate. Nowadays, if you are using the iPhone, if you take a picture, we can separate the human beings. We can create our own stickers by separating the human beings or items of the objects of the particular image. I can see objects properly. Similarly, whenever we are doing the text processing, the advantage will be predict to text analysis. Suppose if you are using the Google Gmail, if you are sending the Gmail or Outlook mail nowadays, hello, how, if you type, automatically it will show the are you, how are you, it is going to, that means it is predicting. Kindly, suppose if you write kindly, then automatically it will give the information about, consider into the, kindly consider this kindly consider this application and looking forward for your response. So these kind of things can be automatically done. And speech, what can be done? We can take the part of the speech and who is the speaker, whether he's having pathology or not, whenever he is speaking in the particular format, based on the based on his information. Sorry, based on his acoustic wave, I can say that. So that is speech related applications. Fine. So coming to the small app. So I think so how humans will see. They will see, okay, it is having long nose. The shape of the mouth is like this. Then it is having cheeks in this position, having long hair, 2 eyes in this direction. So one can say that it is ape. Am I right or not? So since from childhood age, whenever we have seen ape, or whenever we have seen monkeys or any other animals, We are trained in such a way that recognizing the emotions, recognizing the objects automatically. Our human brain is involved with the millions of neurons. Someone is speaking. Yeah, someone is speaking. Please mute yourself. That's it, sir.
Hello, I am muting everyone. 1 second.
Yeah, I'm doing it. Fine. Adam. Yeah. So since our network has been trained in such a same way, whatever I told in this previous example, in the same way, the millions of neurons will be getting trained. They will be connected with other network and they will be connected with other layer. So number of hidden layers are more in our human brain. So they will be interacting with each and they are going to automatically recognize it as a ape. So system will see. System cannot see any information in the form of image as this. System knows only one language, either 0 or 1. Everything should be spent in everything should be sent in the form of 0 or 1. 0 means ground, 1 means voltage. I know only these two things. System will whatever you give, finally it will be converted to zeros and ones. That is the beauty of machine. Now, an image, if it is given, the first part you can see, the first portion will be the 9. So it's human view, that is 9. But how system will see in the sense, it will be represented in the form of pixels, where pixel values are from 0 to 255. 0 is nothing but it is black. 255 is nothing but pure white. So remaining values in between, it indicates the gray. So suppose 14 towards black, 17 towards black, 210 towards white, 233 towards white. If you see 255 clearly, 255 pure white. And one can see 0 also, 0 pure black. That representation. So it's a gray image. The image will be of size m by n only. So it is represented here also, you can see. 255 is pure white and 0 is black, 2 towards black, 5 towards black, then 239 towards white. You can see. So this is the representation of image. Again, this particular 157 again will be converted into binary. How it will be converted? Divide by 16. How many times? I can divide it by 16. 9 times 144. Remaining value is 13. 13 is nothing but D. So 9D is the information. 9D is nothing but 1001. D is nothing but 1101. So it is a binary 8-bit information. So this is the way of so that means 157 will be seen by the system in this way. Again, so that we have to understand here. Yeah, human versus machine view that I explained. This is human view. So which is of width by height or m by n, and x it will be converted into pixels. White is nothing but 255, where black is 0. Is there any zero proper 0 here? No 0. 12 is there. 12 and 14 and 11 are there. So 11 is here. Sorry, white it is right. 14, sorry. I can say 14. 11 also. This is 11. Yeah. This is the representation. That means M by W by H matrix. In case if it is a color image, so our entire world will be represented by using 3 colors, that is R and G and B. R is having values from 0 to 255. Green is having values from 0 to 255. Blue is having values from 0 to 255. Total number of colors are is equivalent to 256 into 256 into 256. That is 2 power 8 into 2 power 8 into 2 power 8. Which is equivalent to 2 power 24. 2 power 24 is nothing but 2 power 20 into 2 power 4. That is 16 mega colors are available in the world. Fine. 16 mega colors are available. All are the for all these things, the primary colors are RGB. If you go to paint shop any day, anytime, so they are, if you ask for a particular, they will give the color, color histogram, that is color code book. Color code book they will give. So if you specify, okay, I need this color, this particular color for my house, then what they will do is they will take bucket with white color. Then they will mix whatever the ratio that you have to put in the form of red, green, and blue. They'll put it and they will give it to the machine and it will rotate. These days, wheels are also became famous. So it will rotate and we'll get the proper color what we want. So that means in paint shop, there won't be any particular color. Even if you're purchasing vehicle also, vehicle will always come up with a black color. There won't be any particular color in the vehicle as well. Not black, it is yeah, black, not that is what we can say that that color exactly it will be relevant to gray and cement type it will be there. So they will put whatever the color we want based on the using that machine itself. See, fine. In this case, an image is represented with m by n by 3. These three indicating the 3 dimensions, red, green, and blue. So that's why. So it is red portion and it is green portion and it is blue portion of the same image. So that means this particular value is 8 points of red, 15 points of green, and 14 points of blue is equivalent to this particular portion. Understanding, fine. This is the representation. Everyone, is it not? Is it boring? It's fine. Can I have one? Is it fine?
Yes, sir.
Yeah, thank you, thank you.
Yeah, going good, sir.
Yes, sir.
Fine, thank you so much. Yeah, similarly, if you want to represent this particular 8, it will be represented in this format, red, green, blue. So I don't want to spend much time on all these things. Similarly, a cute puppy can be represented in the form of red, green, blue like this. Now, if you want to convert any color image to gray color, that means if you want to convert this puppy to the gray color or monocolor, then what you can do is you can take the 141 red portion, 35 red portion, 31 blue portion. So that is 141 plus 35 plus 31 by 3. That is equivalent to 7 and 7, 10 and 207. 207 by 3, which is equivalent to 6. And 27 is nothing but 9, 69. That means towards gray color. It will be in the form of gray color. So entire image will be converted into gray by taking the mean of these 3 pieces, red, green, blue combinations. So the same thing has been represented. Is it fine? Yeah. You can see these 3 combinations will be taken as average and total. These slides I had put with a lot of efforts on that. I had done proper animation to make people to understand easily about the concept of scenes. Yeah. The next important thing that I would like to explain here. Let me remove any annotations if they are there. Yeah. Then the concept of convolution I would like to explain. Convolution is nothing but pixel to pixel summation of pixel to pixel multiplication values. Suppose if you are having a pixel window like this, a portion of the image has been taken. Let us assume that image is of 128 by 128 or anything. I had taken a portion of image which is 3 by 3 and window size is 3. Then I had taken a convolution value, that means a filter is the Sobel filter that identifies the horizontal edges. It is of size 3 by 3. Convolution will happen is nothing but this 152 will be multiplied with the -1 plus this value will be multiplied with this value. 68 will be multiplied with 0. And 125 will be multiplied with 1. 78 into -1 plus 85 into 0 plus 1 into 89 plus 214 into -1 plus 50 200 into 1. this value, you will get one single value. That value gets replaced in the center portion of the window. Then we'll shift the window by 1 bit. Again, we'll perform the convolution. We'll get the new value. So that is the beauty I will explain how. These things I already discussed how a neural network will be working. So if it is a 3 by so that is x1, x2, xm up to xm values given to the w1 to w2, wm and wm values, and one bias value for the will be added. So these things we have discussed. Now this part is completely done. That means this part explanation is done. That is NN part. Now I'm going to explain about the CNN part. So where image will be divided into windows, part of windows like this. Fixed size windows. You can see an image with the windows. An image with windows in the sense, suppose if your window is having like this. You can see these portions easily, right? Similarly, you can see the image also in this format. Now we are going to the convolution process. After giving it to the convolution process, we'll get to some other image. Then we'll give it to the pooling window. We'll get some other image. Again, convolution pooling, and this will be happened repeatedly. You can use 5 to 6 convolution processes depending on the application that we are going to do. 1 second, let me take some water. So this is the flow of image classification. You can understand now. I'll give in detailed explanation in the next slide. I have prepared this slide with a lot of interest. Yeah. How convolution process will work? Let us assume that the image is of size 6 by 6, not 128 and all those things. It's of size 6 by 6 image. Then a window is of size 3 by 3. You can imagine this is the window. And this already I had done in the form of animation. I need not put it actually. Yeah. Observe the carefully. There are 2 filters I have taken. Filter 1 and filter 2. Okay. Filter 1 is of size 3 by 3. Filter 2 is of size 3 by 3. Original image is of size 6 by 6. Okay. Then 1 into 1. How much value? 1 into 1. Can someone respond if they are interested? 1 person. Just for mathematics process. Anyone is interested? Otherwise, I'll proceed. Yeah, fine. So 1 into 1 plus 0 into minus 1 plus 0 into minus 1 plus 0 into minus 1 plus 1 into 1 plus 0 into minus 1 plus 0 into 0. Sorry, 0 into minus 1 plus 0 into minus 1 plus 1 into 1. So that means which is equivalent to, I can say simply since all other 0, 1, 1, 1, it is equivalent to 3. This value gets replaced by 3. This value gets replaced by 3 in the sense I'll get a new image. The first value will be 3. Then I'll shift the window by 1 step. Here it will be called as stride. Whenever we are running or walking, your leg difference, it will be the stride. How much speed you are putting your legs. When you are walking like this length will be this length of 2 legs will be called as stride. Those who are running or those who are walking, they can see that these kind of parameters in your from your smart band or from your walking applications as well. So this will be called as stride. Some people's stride will be this much. Some people's stride will be this much. Some people's stride will be this much. Suppose if you're running like this, then your stride will be less. If you're running like this, sprints stride will be more. Those who do sprints. Fine. Here stride is equivalent to 1 because 1 shift. If stride equal to 2, it is a 2 shift. You can understand that. Now, a 6 by 6 image, if you do convolution with 3 by 3, then it will be converted to 4 by 4 image. Now you can ask me, sir, is there any rule for this? Yes, that is 6 minus 3 plus 1 by stride length. 6 minus 3 plus 1 by stride length by 6 minus 3 plus 1 by stride. That is 6 minus 3. Stride is equal to 1. So 6 minus 3 plus 1 is nothing but 4 by 4 image. In general, if your input image is of size n by n and the filter is of size f by f, then your stride is equivalent to something. Then it will be n minus f plus 1 by stride length by n minus f plus 1 by stride length. This is the formula that you have to follow. It is always true. Got it? So that is one thing. Fine. Now consider on filter 1 if I apply. This window has been applied. Dot product if you do, the first window multiplied with convolution, the first window convoluted with the convolved, sorry, not convoluted, convolved with the filter 3 value and stride equal to 1. Stride equal to 1 means 1 shift right. Clearly you can observe stride equal to 1 is nothing but 1 shift right. Minus 1. Likewise, if stride equal to 2 is nothing but 2 shifts right. Likewise, you can shift. So anyways, I given the application of example with stride equal to 1. So the value is 3. Then this value is 1 minus 1 plus minus 1 plus 1, that is minus 1. Okay. Then next one is minus 1 plus minus 1 plus minus 1 minus 3. Likewise, you can imagine this one is minus 1 minus 1 1 minus 1. Now 1 shift down. Previously the window 1 shift down. Since stride equal to 1 shift down. Then it will be minus 1 minus 1 minus 1, that is minus 3. Likewise, you can imagine all these values. The last window is 1 1 1, that is minus 1 1 minus 1 minus 1. This is a 4 by 4 image. That means 6 by 6 image convolved with 3 by 3 is giving 4 by 4 image with filter 1. Now, if you are applying on filter 2, filter 2, then you will get 1 0 0. So this will, the filter is this one. It will be 1 minus 1 minus 1 minus 1, and similarly minus 1 1 minus 1, that is minus 1. Then minus 1 1 minus 1, that is minus 1. Then 1 minus 1 1 minus 1 minus 1. Likewise, we'll get minus 1 and total values. Last window is 1 1 1, that is 3. This way we are getting the 6 by 6 convolved with 3 by 3 and 2 such filters. This is number of filters. Will result 4 by 4 by number of filters, that is 2. Now you can imagine 128 by 128 image. If it is convolved with 3 by 3 by 64 filters, then the resultant image is 128 minus 3 plus 1, that is 126 by 126 by 64. This you have to understand in the first step. Now, then what we will do? We'll do pooling. Pooling is nothing but the advantage of pooling is one second. Yeah, fine, no issues. The advantage of pooling is convolution. This is the process. Yeah, I explained here clearly. The 6 by 6 image convolved with 3 by 3 by 2 filters will be resulting into 4 by 4 by 2. Okay, now I'm performing the pooling operation. See, Yeah, and don't go with these noises. Yeah. Pooling I'll do. Let me explain about the pooling now. Then I'll come back to the diagram again. 4 by 4, our result is there, right? Yeah, this is the result that we get. Then what I will do is, I will take sub windows 2 by 2 if it is a pooling of size 2 by 2. Then 2 by 2, 2 by 2, 2 by 2, 2 by 2 I will take. Then I will take the max pooling. If it is a max pooling, maximum of this window 3. Maximum of this window 3, 0. Maximum of this window 3. Maximum of this window 1. That means this matrix will be converted to 3031. That means, what is that? Sir, why you are doing all these things in the sense? If you see the board image of this much, and if you take the subsamples of this particular board and if you reduce like this, then nothing. That means you can see the board. Similarly, system also, if we are giving this much of object, and if you are showing the subsample of that particular object, system can see. It can recognize. So the same thing, whatever I explained, is the max pooling. Y is nothing but the same thing. So if the board is there in the pixel image of bigger image, and if you take the subsamples of those image, there is no change in the visual perspective, visual perception. So that is the advantage of pooling here. Now come back to this diagram. I want to make it difficult to understand. So initial image 6 by 6. Then I applied 3 by 3 filters. 2 filters. I got 4 by 4 by 2. Then I applied the pooling. Then I got 2 by 2 by 2. Then now let us assume that I don't want to do this process. 2 by 2, 2 by 2 by 2 is nothing but how many values? 8 values. 1, 2, 3, 4, 5, 6, 7, 8. These values are given to this particular 1, 2, 3, 4, 5, 6, 7, 8. These values are given as an input to this. Here I have used 128 layers. Let us assume that. Here I have used 256 layers. Here 4 output. So the 8 by 128 plus 8. This is the value X. Similarly, 128 by 256 plus 8 plus 256. This is Y at this stage. Then 256 by 4 plus 4. This is Z. That means these X plus Y plus Z parameters are used in this particular network. That is the beauty of it. You can understand. So an image is given to the convolution. Then after that pooling, if you want to perform again convolution, you can perform again pooling. The combination of convolution and pooling will be giving the final matrix. Now that matrix will be converted into flattened single, that means one-dimensional vector. That one-dimensional vector will be fed to the neural network, where that neural network is a deep neural network with more number of hidden layers and more number of hidden neurons. So deep is nothing but its number, the network size is large. That's it, which can understand the deep patterns. So finally, you can recognize whether it is a cat or dog. Is it clear to everyone? Till now, am I fine? Is it making sense? Can one not respond? Is it fine, right? Yeah. Now we shall go with this example. So the same thing, how flattened all these things are explained. Now you see, if an image size is 25 by 28 by 28 by 1, so 28 minus 3 plus 1, that is 26. It will be converted to 26 by 25 3 by 3 filters are used. 28 by 28 image. Then it will be converted to 26 by 26 by 25. You can see. Then 26 by 26 by 25 will be converted to max pooling. That is 13 by 13 by 25. Yeah, 26 by 26 by 25 has been converted. Then after that, it is converted into 13 by 13 by 25. Again, we have performed the convolution with 50 filters, 3 by 3. Then it will be 11 by 11 by 11 by 11 by 50. Sudhir sir and Raj sir. Raj sir also. Uh, 11 by 11 by 50. Again, applying the max pooling. It will be 5 by 5 by 50. Now this 5 by 5 by 50 is nothing but how many values? 25 into 50. 1250 values. Totally, if we do flat, 1250 values. That means 1250 input neurons will be there in the input layer. This is the beauty of understanding. So this is what I wanted to explain clearly about the convolution process. Many will say that convolution process is a black box. Convolution process is not a black box. One have to understand thoroughly before applying it to your own application.
Hello, sir.
Huh, sir. So tell me.
Hello.
Raj sir, tell me. Is it audible?
I'm audible, sir.
Sir, tell me. Do you want to speak anything, sir? I think some network glitches are there. I'm muting yourself. I'm muting from my side. Yeah. Fine. Now coming to the hands-on. Now, by this time, Sambashwara sir might have shared the document with everyone, right? If it is shared with everyone.
No, I have not shared, but I will share, sir. Have you sent to WhatsApp?
Yes, sir. I have sent it to your WhatsApp.
Right now, I'll share to the group. Okay, thank you.
Now I'll explain the hands-on properly with that particular document. That is MNIST dataset. Actually, MNIST it is a standard dataset for images. It is having around 1,14,000. How much totally? How many? 60,000 training images and 10,000 test images. Generally, it is a OC digit characterization. That is optical character recognition of the digits. MNIST dataset is a digit recognition dataset. So I can explain the dataset as well if you want. Now, this MNIST dataset is a standard dataset that is for basic application I had taken. It's a modified National Institute of Standards and Technology, MNIST stands for. And it is having the 28 by 28 image pixel images, 60,000 images for training samples, and 10,000 images for testing. So it is having the images like this 0 to 9. One can see the images. Zeros will be like this. Once handwritten 0 to 9 images. That means 10 classes. Totally 10 classes are there. So the 10 classes, how we can classify, I'll explain. In a Jupyter notebook itself. Python experiments. Let us assume that hands-on. Keep me folder. So hands-on. NRI IT. New Python file. Everyone, please open this particular document so that we can do things parallel. So CV2 package, NumPy package, matplotlib.pyplot package, pandas, and TensorFlow.keras.datasets. In TensorFlow keras.datasets, MNIST is there. So import a CV2 for viewing the images and all those things. Import NumPy as NP. Should I increase the font? This is fine, right? Import the pandas as PD. Import the matplotlib dot pyplot as PLT. Import the TensorFlow dot keras dot datasets. Import MNIST. It is from. These are the things that we can do. Anyone is interested to do the hands-on parallel with me, or should I go with my flow? If anyone has opened the Jupyter and if they wanted to hands-on with me, then I'll go a little slow. May I know if anyone is interested?
Yes, sir.
Okay.
Yes, sir.
Fine. You can open your Jupyter Colab. You can do it in Colab as well. If you don't have Jupyter, just colab.research.google.com. I will do it in Colab only for your purpose, so that you people can be parallel with me. New. Hello. So this is a digit calculation. Digit recognize. If small internet is there, there's enough, and if you have a Google account. Starting, I'm generative. We can generate the code with AI also here because of Gemini. Fine. Import CV2. Import NumPy as NP. Import pandas. Yeah, I always suggest you to use the Gemini or code ChatGPT and all those things if you are proper in analyzing the coding. Otherwise, don't use. Even if you want to write a paper, you can make it ChatGPT as co-author also. That means you can take the data from the co-author ChatGPT, but if you know the complete concept, pandas as PD, and import matplotlib, pyplot as PLT, and from TensorFlow dot keras dot datasets, import MNX. Let it get. Meanwhile, I'll increase the font of this. Is it fine? Is this font fine for everyone? Is this font fine? Hopefully it is fine. Yeah, I could see on my other machine. The font is looking fine. Anyways, I'm not buying it. Should I generate it? With A? Yeah, what we can do is I can explain. Yeah, MNIST load data from MNIST and copy to Xtrain, then Ytrain, Xtest, and Ytest. Simple. See, Xtrain, Ytrain, comma, Xtest, comma, Ytest is equal to MNIST dot load data. Can we do like this, or should I type? What is your interest? Should I type the code, or otherwise can we do like this? This is okay. Yeah, fine. Accept all 4 variables. Yeah, so now accept this part. Accept extend shape and y, all these things. Simply I'll keep it as x underscore prime dot shape. Yeah, I can see. I'll keep it like this in submissions. Asserting is done. Then, if you want to see the shape of x prime, display shape of x underscore prime. X prime dot
90
shape.
rupees.
60,000 images are there. Each image is of size 28 by 28. Plot some random 5 images. From training data.
అటువంటిది ఇవ్వండి సార్.
With a function, plot data. Define plot data, x train and y train. Okay. So import random indices, random dot sample range. That means total range is x train underscore shape of 0. Shape of 0 is nothing but it will give 60,000. You can try it here.
మీ బిఏ క్లాస్ ఉన్నట్టుందిగా ఇప్పుడు. క్లాస్ క్యాన్సిల్ అయినాయి ఏమన్నా?
Sudhir sir.
ఇవ్వాలి.
Sudhir sir. Yeah, thank you. 60,000. No issues. 60,000, 5. That means I wanted to generate a random sample, random number, 5 random numbers. This is the code. It will be doing that, generating the 5 random numbers. You can see if you want. Random indices. What is that? Random is not there. Import numpy dot np dot random. Otherwise, import random should be there. Random indices equivalent. So some 5 random numbers: 54,277 image, 52,314 image, 24,147 image, 26,767 image. So likewise, 5 random indices will be generated randomly. Oh, each image display in the form of gray and x underscore train of y plot data. See what it will do. It's generating 5 images. You want to do it properly? We can do it in the form of subplots. Yeah, let us assume that I want to generate 16 images of this type. Then, yeah. Pig comma axis is equivalent to plt dot subplots of 4 subplots. 4 x size is equivalent to 6 by 6. I want to give. Whenever plotting is happening, simply I'm doing this. X dot im show of x underscore prime of I. Ax setting. Im show cd2 dot im show. You want to show from data. Numpy array has no attribute of for I comma Ax in random indices. X. So there is a, what is the error? Cannot enter. Okay, I'll use my code only. So it is rand IDs equal to np.random.randint of 1 comma x underscore train dot shape of 0 comma 16 such images you have to display. Yeah. Then axis pic comma axis is equivalent to plot dot subplots of 4 comma fixed size is equivalent to 6 by 6. Then for I comma ax in enumerate of axis dot flat. How it is generating the code as nothing. It's the beauty of see some random how images looks like. So I want only 9, 3 by 3 I can do. Three, 9, 4, 0, 1, 9, 1, 2, 4. 9 images have been displayed. So if you can understand this code, you can use ChatGPT or Gemini, whatever AI tools that we had in the currently available market. Gemini is of Google. ChatGPT is there one more. So next, generate the code. We shall do the generating code only. Import all the TensorFlow related packages. Import all TensorFlow, Keras, and then layers, then model, and model checkpoints also. Let's see. Import TensorFlow ST, import TensorFlow from TensorFlow, import Keras, from TensorFlow.keras, import layers and model, from TensorFlow.keras.callbacks, import model checkpoint. How beautifully have been imported all these things. Can I proceed like this or should I type? Someone can say. Quickly, because I have only 20 minutes left. Okay. It's okay to proceed like this, right? Fine. Then, now I'll describe little better way. Generate, build model, function that takes input shape and the number of classes as parameters. With 32 convolution filters, with filters, convolution filters, 32, 64, and further flatten 32 and 64. Then flatten contains 120 renal neurons with one hidden layer. Use softmax function at the last dense. Build model, input shape, comma number of classes. Model equal to Keras dot sequential model. First convolution is having 32 filters. The filter size is 3 by 3. Activation is ReLU, rectified linear unit. Input shape is equivalent to input shape that I am going to provide. Where input shape is equivalent to, I am going to provide it as shape of 1, 1, shape of 1, 1. Next layer, 64 layers. Kernel size 3 by 3. Activation equal to ReLU. Then flatten. Then we use 128 hidden layers in the hidden neurons in the hidden layer. Then finally, number of classes, written model. Now, can anyone tell me how many hyperparameters are required for this particular code? Then I will understand how far you understood this. Quickly, can anyone tell me how to calculate? Is it possible? Can anyone calculate quickly? See, anyways, I'll explain. Input shape is 128 by 128. Given to 3 by 3 filter. It is 126 by 126 by 32 filters. Then max pooling. Max pooling, if you do 63 by 32 after max pooling. Then give it to the next layer. 61 by 64 filters. Again apply max pooling. That is 30 by 64. Flatten all these values 30 by 64. That is 900 into 64. How much it is? $57,600 inputs. Inputs into 128 plus 128. So 57,600 into 128. That is 73, 72, 800 plus 128. 73, 72, 7, 928. These many weights are there. Then 73, 72, 9, then 128 by 10 will be connected to 10 plus 10. That is 1280 plus 10. That is 1290. 73, 72, 928 plus 1290. 73, 74, 218. These many hyperparameters are. If you know this level of understanding the CNN, you can do magics with the ChatGPT now. Generative AI. Sim can play magics. See, I will show the model summary. Okay, I have to call the call build model. With 128 by input shape is x underscore train dot a shape of 1 comma x underscore train dot shape of 1 and number of classes 10. Number of classes is 10. Input shape is equivalent to shape of 1, 1, 1. Number of classes 10. Build model of input shape. Print model summary. Now I am going to print the model summary. See, initially, sorry, it is 28 by 28 image, sir. I'm sorry, I had taken wrongly. I will evaluate it properly. One second. Sorry, 28 by 22 is right. So one can understand input size is 28 by 28. After giving it to 32 filters, it is 28 minus 3 plus 1, that is 26 by 32. Then give it to the max pooling, 13 by 13 by 32. Then give it to the next level, 64 3 by 3 filters, 11 by 11 by 64. Give it to max pooling, 5 by 5 by 64. 5 by 5 by 64 is nothing but 5 into 5 into 64. 1600. So the total number of platen is 1600 values. 1600 into 128 plus 128. 1600 into 128 is 204800 plus 128. 2068089. Then it is given to the number of classes. 128 by 10 plus 120 10. That is 1290. 206089 plus 1290, that is equivalent to 207379 parameters. You can see. Understand it. 26 by 26 by 32. Total parameters are 320. After doing the max pooling, it is 24. 26 minus 8, 24 only, sir. My mistake, my calculation mistake. 24 by 24 by 64. In between, we have to do the max pooling, right? Do max pooling of 2 by 2 filters. So, 64. Do max pooling of 2 by 2 at each convolution operation. Max pooling 2D. That's good. This max pooling 2D, yeah, layers only, right? Layers. Yeah, 26 by 26. Initially, convolution is 26 by 26. I'm correct only. Yeah, 26 by 26 by 32. Then 13 by 13 by 32. Yeah, after max pooling. Then 11 by 11 by 64. That is next layer. Then 5 by 5 by 64. Next layer. Totally, now 1600 total. Flattened values are 1600. Then 1600 into 128 plus 128. That is 204928. Maybe my mistake. Calculation mistake. Yeah, fine. 204928. Then 10, 1290. 204928 plus 1290, which is equivalent to 207. The total values will be the summation will be. So 320 plus 18,496 plus 20498 plus 1290 will be the total number of parameters, which occupies 879.04 KB. See, I didn't write any code here. Everything has been generated by GenAI, but I know the complete internal process, what is going to be happen, which is most important thing that you have to understand. Okay, so then simply I'm going to train and classify. We shall see how it looks like. Training and classify. Fit model, generated code. Fit model of X-train, Y-train, epochs. Generative function. Fit underscore model. With the model, with parameters, model, X underscore train and Y underscore train and epochs that gets trained with the train data set. Fit model X-train, Y-train and epochs. Model.compiler optimizer, they have used Adam optimizer. Loss is equivalent to sparse category across entropy. Metrics is accuracy. Model.fit of X-train, Y-train and epochs equal to epochs. Simple. Return model. Now call the model. Next thing is call the model. Yeah. Also display, fine. Yeah, call the model, that is history. Generate a, call the model, fit model, and display last function, display last function, plot last function, and display accuracy. assuming extend dot si as type of float, so that they are converting into 0 to 1. That's fine. Epochs equal to number of epochs equal to is some 30, 20 should be. Number of epochs equal to 20, fit model of model, all these things. Finally, it is going to plot the accuracy also. So plot the loss and print the accuracy also. So first epoch, the accuracy is around how much? No, I will run it for 10. I cannot run it for this many. I will run it for 10. Yeah, first epoch. Now we can, in between, you can ask questions. Anything. So how is this? And you can give some comments on how is this answer. Is it making sense? Can anyone respond? Is it that tough to type the code? That tough to understand the code? No one is speaking. I mean, meeting. Hello. Can see only like symbols. No one want to speak about. Someone can give oral feedback if they executed this and they understood properly. Yeah, after first iteration, the accuracy is around 60%. After second epoch, the accuracy is around 94. We shall run only 3 epochs because it is taking too much of time. Now we can give some comments on the explanation. So some comments, sir. Sir, I think the time is over. If they run and execute, they will understand the properties. We thought of explaining the time series analysis forecasting also. Due to time constraints, I want to give complete idea about CNN. Later on, we can do magics with the images. Samshaya, sir?
Yes, sir. Yes, sir. I think you can conclude, sir.
Yeah, with this, what I would like to conclude is one can perform any kind of image processing tasks. I'll share 2, 3 applications with Samshaya, sir. You can experiment with them, and the data sets are available already. I'll provide the data sets link as well, how to include the data sets in the code itself. So with this explanation, we can try and we can understand how this CNN works and at each and every layer. And after each and every layer, how the values of the dimensions of the images will come down. So how subsampling will be done, and finally how it will be given into the neural network. One can easily understand the complete process. We can do magics with the advantage of this Gen AI. So Gemini, nowadays we need not write any single line of code. You can just tell, I want this code. It will generate the code for that.
Yeah. If there are some 1 or 2 questions, we can pick up, sir. So, dear
Please,
participants,
yeah,
we welcome your questions.
can expect 1 or 2 questions.
Yeah.
We are giving claps and like symbols. If you give oral feedback, that will be good because it is getting recorded, right?
That itself is a moral support to us.
Yeah, 1 or 2 oral feedback is always good from the session. So I'll be happy.
Undoubtedly, the session is really well. So it is completely illustrative and hands-on also.
Thank you so much, sir.
Yeah. So thank you, sir.
And thank you so much, sir, for giving this opportunity to deliver a topic. And,
Yes,
and the thanks to the management of NRIT also, also, and especially many thanks to you, sir.
And also to
AACT.
AACT. And also to AACT for guiding us.
AACT, because funding is provided by AACT.
Yes, yes.
Thank you so much.
Thank you, sir. I request Shobana Madam to propose vote of thanks.
So as AACT trusts you like anything, sir. Whatever the application that you send to AACT will be always positive to you.
Yes, sir. Sir, this is my 9th FDP, sir.
Ninth one. Out of that, I had given 3 in 3 AACT talks. I had given, sir, 3 or 4.
Yes, sir. This is my 9th FDP with AACT funds.
Yeah, they trust you like anything, sir.
And yesterday,
and you will do systematically all this.
Yeah, in 2022, we conducted an international conference with AICT funds. Yesterday also, I received one more grant to conduct international conference.
Yes, sir. I'll be part of it. Thanks.
Yeah. Yeah. So, I'm going to display that to our participants. Yesterday, I received some grant from ANRF, Anusandhan Research Network. Anusandhan Network Research Framework. That is, earlier it was SERB online. Yes, sir. Yeah, Shobana Madam, please
Yes, sir.
propose vote of thanks.
Yes, sir. Very good afternoon, sir. It's my privilege and honor to deliver the vote of thanks for today's session 11, a hands-on session on implementing algorithms for predictive analysis. Sir, which you showed a very realistic. We learned so much on CNN. Firstly, I extend our heartfelt gratitude to Dr. Vishnu Murthy for sharing his invaluable expertise and insights gained over his 12 years of experience in his field. Sir, your session has been both enlightening and inspiring, offering a practical knowledge and hands-on skills that will surely empower us in the realm of AI and predictive analysis, sir. Thank you very much.
Thank you very much. I think it's echoing.
Yes, sir. Yes, sir. Yes, sir. Thank you very much. Thank you, Vishnu, sir, for all your efforts and time to our Atal FDP program. Hope to see you in future.
Definitely.
Future activities. Thank you. Thank you very much.